Today I'm actually sharing with you some of the questions that look similar but not really that similar. I want you to be able to spot the difference between the questions, how the question asks, and based on what you can use what method to solve the problem. Okay? One of the questions that I'm going to go through, I actually gave you on the 20th of June 2022, question 1. But as you do more questions, you have to try to consolidate in your mind what are the similar questions and why sometimes these questions I must use this approach and this question I have to use another approach. So you must be able to spot what is the difference between the questions. Okay, we see this question. Angel has some chocolates. She packed 5 into each bag, and then she will have 2 extra. If she pack 8 chocolates into each bag, she will have 3 extra. Okay, how many chocolates does Dawn have? In this case, I know I have chocolates, important thing. And then another one is pack. So, I know that you have to ask yourself, is the total number of chocolate the same? Chocolates. Very hard to write using this. The same. Okay, this is one. Yes, it is the same, right? Because this chocolate she can pack into 5 or she can pack into 8. So the number of chocolate is the same. Then what about the number of packs? Will it be the same? No. Let's say I have 10 chocolate. I decide to one of them I pack 5. Then I can only pack 2 bags. Another one I decided to pack 2 into 1 bag. Then I have 5 bags. So the number of bags will be different. In such cases, I know the total number of chocolates will be the same. So how my approach in doing this kind of question is, I want to make sure I have to do the multiple until I have to make sure the 8 packet and the one I pack 8 packet and the one that I pack 5 packet will give me a total number of chocolates. And then this is how I find what is the number of chocolates does Dawn have. Okay? First, if I pack 5 packet, 5 in the packet. So if number is equal to 5, my first packet will be, okay, so let's do this. If this is number is 8, my first packet, here will be 5, right? But then you know that I will have an extra 2. So my total, not my fault. I mean, it's very hard to write on this pack 5. Okay, my total, this is 5, right? My total will be add 2, right? So if I pack 8 packets, my total will be, I have 3 extra. Total will be at 3. Correct or not? Let's do a 9 here because I don't want to mix up the 2 of them. So my first packet is 5. 5 add 2 is 7. 7. This is the first packet. What about this one? The first packet is 8. 8 add 3 will be 11, right? I can do this. And draw a line. And the total is very important. This is where I can find my answer because I know that total is the same. Okay, so then my second packet, multiple, right? 5, then the next one will be 10. Then over here will be 12. Then here 8, right? My second packet 8, 16. And then this one will be 19. 12, 19. Let's come back to this. 3, the third packet 15. And then I will have 17. Okay, 17 is still lesser than 19, right? And go to 4th packet with 20. then I will have 22. Okay, so then I go back to here because this one is more than this already. So my third packet will be 24. Then my total will be 27. Let me see, I hit 22 already. The fifth packet here, 25. My total will be 27. So I know that the total number of chocolates is the same. So what is the total in this case? 27. So if I pack 5 chocolates in 5 packets, I will have 25 with 2 extra. If I pack 3 packets of 8 chocolates, I will have 3 extra. So this is how I find the total number of chocolates, because I know that only this is the same, but the number of bags is different. This one use what? 5 bags, and then this one use 3 bags. Okay, we go to the next question. It's chocolates again. So you will see very similar question, but then how come the approach of doing it is different? We come to this. Angel has some chocolates to give to her friends in the party. Now I have friends. Okay, if she give 5 chocolates to each friend, she'll need extra 2 chocolates. If she give 8 chocolates to each friend, she'll need an extra 14 chocolates. So I know I have chocolates and I have friends. So I ask my first, the total number of chocolates, is it the same? Yes, it's the same, because it's not like day 1 I have how many number of chocolates, day 2, it's just that I have that amount of chocolate for the party that day. So total number of chocolates is the same. Then I ask myself, now I have friends, is the number of friends the same? Will the number of friends change? Will not change, right? So I have these 2 the same. Then what I can do is I can draw a model. So I let a box, let's say this a box like that, be the number of friends. Okay. That number of friends. Number of friends. So I draw my first one. Both are extra. There is no lacking. So no chance. I just draw. Maybe I draw the 8 chocolates first. So the 8 chocolates. I'll draw. One, two, three, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Then it says what? I will have I need 14 extra. 14 extra. So that means this is not enough. So over here is I need 14 extra. Okay. So this is the 5 chocolates. So let me draw this first. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so 5 chocolate. 1, 2, 3. And then I know that what? I will have 2 extra. I will need 2 extra, not I will have 2 extra, sorry. I will need 2 extra. So this one is also lacking lah. Correct or not? But this time right, I will need 2 extra. Okay? So can you see that the difference is 3 unit. And then this over here, the difference is 12. 12, correct or not? So 3 unit will be equals to 12. 1 unit will be 12 divided by 3 will be equals to 4. So I say let the box be the number of friends. So I already know that this one, a box like that, a box already know that this box that means 3 box, because 3 box is equals to 12, right? 1 box is actually equals to 4. So number of friends equals to 4. Okay, can you see that? Number of friends equals to 4 because box is the number of friends. Okay, how many chocolates does Angela have? And Angel have. So you know that the total number of chocolates is the same, correct or not? So what I can do is my first is this one is 8. The total numbers. 8 unit minus 14, right? This is total number, ma. So I know 8 times 4 minus 14 will give me a value of 8 times 4 minus 14 should give me a value of 18. And it should be the same because the number of chocolate is the same. Over here is what? It's 5 unit minus 2, correct or not? So if 5 times 4 minus 2 also give me 18, correct? Okay, let's go to next question. This question you did before. I'm not sure if you still remember or not. Maybe you can just look through first. Okay, this time round I have a group of boys. Share some cards. Now I have cards, game cards among themselves. Okay, but each of them take 9 cards each. The last boy only got 4 cards. Okay, so but then when they took 7 cards each, there were 13 cards left. So I asked myself, is the total number of cards, game cards, the same? Yes, it's the same. Then what about the number of boys? Would there be any changes? No, the number of boys will remain the same. Don't you feel that it's very similar to this question? Because both I have 2 is the same. So what can I do? I first draw. I say, okay, let one box, let the box this be the number of boys. Okay, number of boys. So I know that if each of them get 9 cards, right? So 9, if each of them get 9 cards, so I just draw. I will have what? Only the last boy will got only 4 cards. So I put here 1. How to draw it here? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So the last boy here will only get 4 cards. Okay? Which means the total number of cards is, this is the total number of cards. So what about 7 cards? For the 7 cards, they will have an extra of 13. So I draw here. 1, 2, 3, 4, 5, 6, 7. Know the number of cards end here, right? So this is extra of 13. Okay, let me see. This one, you can clearly see. From here, you can clearly see. If I take 13, 13 minus 4 equals to 9. So one box here is actually 9. And box is what? Box is the number of boys. So there are 9 boys. Correct? And then how many games cards are there altogether? You can either use this equation or you use this equation. So let's say if I were to use this, I know that one box is 9. How many boxes I have? 1, 2, 3, 4, 5, 6, 7, 8. Because the 9 box, the last guy only get 4. So I have 8 times 9 add 4 will give me 76. And then this should be the same for this. So I have 1, 2, 3, 4, 5, 6, 7. 7 times 9 add 13 will also give me 76. Okay, so you see what is the difference? Although the question look very similar, but then because of the difference, your approach is different. Okay, we come to this question. This is one of the questions that I actually saw online, and I actually find it's quite interesting because I remember that I gave you a similar question, and but that similar question, I'm not too sure if you know what is the difference, how to apply it. So for this one, John and Kenneth have the same number of sweets. Told you already, same number of sweets. So my first point is total number of sweets. Sweets is the same. Nice. Okay, but each of them pack his own sweets into packets. So I have another thing now here is packets. But John packed 5 sweets in each packet and had 2 sweets left. But Ken packed 8 sweets into each packet and will have 4 short of 4 sweets. So I know that, you see, it's very similar like this question, right? I know that the number of packets is different because it packed different now. So number of packets is different. So this is not the same. But then another thing very interesting. Now it's asking you if how many sweets did each of them have if they use the same number of packets. Or this condition changed already. For this condition, you count the same number of packets. Correct. So if this condition met and this condition met for A, remember, I can just draw my model. So when so this is for A, whereby this and this is the same number of packets. Okay, Ken, what? 8 sweets in each packet and then short of 4. So 8 sweets and then short of 4. So I just draw 1, 2, 3, 4, 5, 6, 7, 8. Short of 4. So this is this side here. This is short of 4 . So the other one will be John. John is actually what? 5, and then there will be 2 sweets left. So put all this down. John will be 1, 2, 3, 4, 5. And then I will have what? 2 sweets until here, right? Here's 2 sweets. This is not so direct as in this question, correct? No, not so direct as in this question, because this you can easily find that this one box number of boys is this one box. Okay, so it's asking you if number of packets, this one box is number of packets, okay? This one box is number of packets. So it's asking you, because here say number of packets is the same, correct? This one, then that's why I draw this. Okay, I hope until here you understand. But this is not as straightforward as the one, because this one 2, then I have 1, 2, 3, 3, this 2 box like not so close like that. It's not like the full box. So what I can do is, I have this 3 box, right? Correct. And then I have 2. If this 3 box minus away this thing here, minus 4, because I know this is 4 then it's equals to this 2 here. Don't you see it? Can you see it? If this thing here, wait, this thing here, this is 3 box. If I minus away this thing, isn't it equals to 2 here? I hope you can see it. So I just do 2 plus 4. So it's 6 divided 3. So it has 2 packets. 2 packets, okay? Because the box is 2, right? It's number of packets. So it's asking you how many sweets did they each have if they use the same number of packets. If they use the same number of packets, they will have, you know, the total number of sweets, right? Correct or not? You can either use this or you use this. It will give you back the same answer. So 2 times 5 add 2 will be giving you 12. Over here you have 8 times 2 minus 4 will also give you 12. So this is 12 okay? Okay, then we go to the second question. Let me drop away the first question because the first question is done. Okay? Bigger eraser. Drop faster. But the second question is a bit different because you can see that the second question, it says, what is the smallest possible number of sweets each of them had if they use a different number of package? So it's the total number is the same, but then the number of package is different. Don't you find it very similar with this? The total number of chocolates is the same, but the number of packs is different. So what I can do is I have to do this method. This method whereby I have to find the multiples of 5, and then I also find the multiple of 8 until they give me the total number of chocolates the same. In this case, it's sweets. Okay, so just push this out a little bit, and I have to start my table here. Just draw a line. So this is 5 now. This for 5, and then this for 8. Okay. So my first packet, 5, and then it says if it's, where's my question? If it's 5, right, each you had 2 left. So the total is at 2, right? So it's 7. Total is 7. And then if it's 8, right, and short of 4. So let's say my first packet this is the number. My first packet is 8, and then it's short of 4, the total here, right? It's short of 4, so it's minus 4 lor. Correct or not? Here is minus 4. Then I have to continue to do until I feel the total is the same. So because this one is 4, this one total is only 4, and then that one total is 7. So I do this one, my second packet will be 16. 16 minus 4 will be 12. Okay, then I do here. Second packet will be 10. 10 add 2 will be 12. You see? Do you see? Do you see something here? If they have the same, just now is that question, right? You notice that if they have the same number of packet, the total number of sweets will be this. What is the smallest possible number of sweets each of them had if they use a different? But then this question is not asking the same. It's not asking the same. Different number of packets. So I cannot take this answer. This answer is already the one in front. The one in front you can also do this. But then I find drawing the model is quite easy. So I have to continue my work. So here, if this is 3, then here is 15, right? The third packet. 15 add, then it will be 17. So I come here. The third packet will be 24. Then here is 20. Okay, then I come back here, the fourth. Here is 20, right? Add 2 will be 22. Then 22. Okay, then here I come to the fourth one will be 32. So you see 8, 16, 24, 32 is all your 8 term table. Minus 4 will be 28. Then I come back here. Will be 25 plus 2, right? 27. So I come back here. Here is 40. Minus 4 will be 36. Okay, so I come back here. So it's 30. 30 plus 2 will be 32. 32 is 2 lesser than 36. So I'm trying with 7 packet. 7 packet is 35. 35 add 2 will be 37. Okay, so not this one. So I go to my 6 is 48. 48 minus 4 will be 44. Okay, come back here. This is my 8 one. Will be 40, right? 40, then this is 42, less than this. So my ninth will be my ninth, right, is 45 already. 45 add 2 is 47. Okay, bigger than this. Then I go here. My number 7 here is become 56. Minus 4 will become 52. Okay, let's come back here and see. My 10 packet, this is 50. 50 add 2 will be 52. Oh, total is the same. You see? It's the same. Okay. Now you see, right? What is the smallest possible number of sweets each of them had if they use different number of package? The total number is the same, but then the number of package used is the same. So this one cannot be used to answer this question. But this one here can be used to answer this question because the package used, the number of package used is different. You see? If I pack 5, I need 10 packets and put 5 in. If I pack 8, right, I need 7 packets. 7 packets, 7 packets. To put to put 8 in, 8 in. Okay, if you notice the total number of sweets, if they are packets, the smallest total number, because if they want the biggest then you must keep going until you find another total sweets is the same, and then it's keep going on. It's so you usually will ask for the smallest if the numbers are very big, smallest possible. You must fulfill yes, this is the smallest possible because it's the first number that hit the same with different number of packets. If for the same number of packets is 2, and then the total number of sweets is this. Okay, I hope that you, from all this exercise, you learn how to recognize what are the different methods of doing for this kind of questions. Okay.